Hi all and welcome to the second video of the module, in which we are going to talk about the void and decat vocabularies for describing datasets. The void vocabulary aims to define an RDF dataset using the predicate void dataset. That is, our dataset will be an instance of the void dataset concept. In void, we will deal with four types of metadata. The general metadata containing the main description of our dataset, the structural metadata defining its structure, the description of the link sets defining how the dataset relates to other datasets, and the access metadata, which defines how to access the information contained on it. The general metadata serves for identifying which datasets are useful for us. That is, as we have seen in the previous videos, this information is highly relevant when trying to identify, for example, which datasets are potentially useful for links. It specifies information such as, for example, the description or the contact information, as well as some technical features. For that, it relies on the doubling core and FOAP vocabularies that we introduced in the previous modules. These are some of the main properties of the void datasets, which allow to specify information such as, for example, the title or the description using DC terms, the information source, the creator, or when it was created. As well, it introduces properties from the FOAP vocabulary for specifying things such as, for example, the homepage of the dataset. One of the relevant things that we can specify using void is the license for our data, which will allow users to understand which are the usage rights that they hold over our data. As well, for that we use, the DC terms license property. As well, we can state the category of our data using the DC terms subject property. That is, the information about which topics are covered and which is the domain of our dataset. As well, some technical features can be as well introduced, such as, for example, the serialization of our data using the void feature property to that purpose. Whereas the general metadata describes our dataset from an informational point of view, the structural metadata specifies the inner details about it, including, for example, its internal structure, or which is really useful when exploring or querying our dataset. It also includes information about the vocabularies that were used on our dataset, its statistics in terms of the size of the dataset, and even concrete examples of how it is structured. As we see here, we can include example resources for our dataset. For that, we use the example resource property, which will link to a set of triples containing a general example of our data. We can as well define the type of URIs that our dataset is going to use according to the naming strategy that we defined before. Using the URI space property, you can state that our dataset has a base URI for its data. So, for example, here, this dataset, the Music Brains dataset, will contain individuals that has this URI as the base URI for all of them. One of the important properties to define in the metadata of our dataset is the list of vocabularies that has been used to generate it. By means of the void vocabulary property, we can include the most relevant vocabularies that we have used. That is, if we are going to use several different ontologies, we can decide which ones are the most important and informative ones, so as to annotate them. we have to take into account that we can only specify full vocabularies, not part of them. So we cannot state that, for example, if we are using FOAF, we cannot state which parts of FOAF we are using. We can only say that we are using FOAF as a vocabulary, the whole vocabulary. Finally, it's also important to include information about the statistics of our dataset in terms mainly of its size. For example, the number of classes that it has, as with the void classes property, the void properties, the number of properties, distinct subjects, or even the overall number of tuple. This, combined with the rest of the structural metadata, is really useful to decide which types of queries we will be able to execute over our dataset. The link set information that can be described using void refer to the links between two different datasets. We will identify, as we see here, the type of linking predicate. In this case, we are using all same as to relate two datasets, and the target dataset, in this case DS1 and DS2. So we are saying that these both datasets are linked to each other, their individuals are linked to each other by means of the all same as property. That is, again, useful when navigating the relation between these two datasets. Finally, the access metadata will describe which are the means to access our data. This includes the information about the endpoint, either the lookup endpoint or the Sparkle endpoint, or the root resource of our dataset in the case of datasets shaped as trees. So the main element, the root element of our data. We can actually, optionally, state as well metadata about data dumps, that is raw data, the raw files containing the information of our dataset by means of the void data dump. dcat, apart from void, serves mainly the same purpose as void, that is, describes information about a dataset. As in the case of void, it works around the concept of a dataset and data catalog, including information about it and its related services and, for example, download information among many others. Here we see an overview of dcat. As we see, we have information about the dataset using mainly DC terms properties, as in the previous case, and about its publishers using FOAF agent. So who publishes this dataset? It also uses the SCOS vocabulary, as we see here, to define or to specify the definition of concepts. So, as an example, we introduce here how the data from the Spanish National Library is annotated using, in this case, both dcat and void. It includes information about the license, the creation provenance, and the language and how to access it online. It defines datos.bna.es as a catalog, as we see here, composed by 7 different interlinked datasets, which can be accessed using different mechanisms. As we see here, we are defining the catalog entity as a dcat data catalog with information about the title, in this case both in Spanish and in English, with some extra information using RDFS label that we introduced on the RDF module, information about the homepage, the publisher, which in this case is the BNA representing the Spanish National Library, the access license, and the different languages that are supported on it, which are more than 200. We define, as said before, the publisher of the catalog, saying that the National Library is the publisher of the catalog, and that it is a FOAF agent, which is the same individual as the one stated by this URI. As we introduced, it is composed by 7 different data sets. So we say that the catalog is composed by data sets including entities, works, expression, manifestation, items, subjects, or persons as authors of the different books. As well, we define the information about how to access it. We define, in this case, the URL of the Sparkle endpoint, so we can execute Sparkle queries over this Sparkle dataset. And we have information, again, describing it, textual information in different languages, and the license of each distribution of our data. With this, we conclude this lesson in which we have seen the main vocabularies for describing datasets, that it's void and dcat, which you should use to annotate your dataset before publishing it on the web.